Hello, Nuruddin, over to you.
Okay, so um, okay, can you hear me now?
Yeah, we can hear you.
Yes,
Okay, so thank you because maybe before I begin, I would like to just apologize because my workspace tends to be a little bit echoey sometimes when I'm talking. You can hear echo in the background, so it tends to happen from time to
okay.
time. Secondly, we are all in Nigeria, so I would like to apologize beforehand. Maybe if my network dropped during the call because my
Yes,
backup network,
network.
yeah,
Yeah, it's true.
my backup is down since yesterday. I'm using my mobile for backup, and there is no
Okay.
network since yesterday. So I'm relying on Glow to save me today. And you know it, how
Let's
Glow are.
let's
So
just hope it will not disappoint us.
yeah, hopefully, hopefully.
All right.
So going into our topic of discussion today, today we're going to talk about the introduction to TensorFlow and Keras. And as from the topic, you can see that this is an introductory class. So it's not aimed at experts among us, people that have maybe years of experience. So I'd like to just prepare ourselves. I would just want to introduce the audience to TensorFlow and Keras. So I'm not going to go deep into the technicalities, writing too much code and the rest. This is an introductory session. So before we begin, also, this is just like a sort of a reminder to us. We are all human beings, so it wouldn't hurt to remind ourselves from time to time. So please try to adhere to this community code of conduct. Keep your mics muted unless you are asked to unmute or you have anything to contribute. And for those of us that are very active on social media, maybe you can, Madam Aminu can provide us with a hashtag or people that we can tag when posting on social media. And please try to be considerate and respect each other. So now I'd like to introduce myself to the audience. My name is Nuruddin Sambo. I'm the organizer of TensorFlow User Group Bauchi. Currently, I work as a software developer at Just Electricity Distribution Company. So I'm presently based in Jos, but over the years I had stints working in field of software development, primarily web development and machine learning engineering roles. So you can find me on LinkedIn or GitHub using my username Sambonuruddin. So on LinkedIn and on GitHub, that's my username. So this is what we hope to cover before the end of this lecture. This is a 2-hour lecture, but I will try to squeeze in everything in hopefully less than 2 hours because I don't want to go over the selected time. So I'm going to divide the presentation into two parts. Maybe after the first part, we'll go on a short recess, maybe a minute or two of break, so that we can all catch our breath and maybe bring some water or tea or coffee, because I know we are dealing with developers. So the first part will focus on introducing the participants to what TensorFlow and Keras are, and maybe the reason you might consider using these frameworks. We'll touch a bit about how to get started with these machine learning frameworks and talk about some of the Keras API essentials. So for the second part of the presentation, we'll talk about TensorFlow and Keras for different machine learning tasks. So to cite a few examples without going in depth into any of the examples. Then we'll take an overview of some of the advanced concepts of TensorFlow and Keras. We'll touch a bit about deploying TensorFlow and Keras models. Then maybe if we have time on our hands, we can have some demos. And The reason why this outline is a bit cumbersome is we want to touch about almost every aspect of TensorFlow. You are not expected to know everything today, but just to let you know that these things are possible, or this is what the TensorFlow or Keras framework contains. So now, I'll just give us a moment to get ready, maybe get our notebooks before we begin. All right, so I'm going to begin with a set of assumptions I've made. Maybe as a scientist, we always start with null hypothesis. So my null hypothesis is you are probably here to learn about machine learning because that's what we are doing today. And probably most of us are familiar with Python because I know we have been having these classes for the past 7 weeks, as Malam Amin has mentioned. And from the outline, we have treated almost all the preliminary aspects, what is expected of you to know before you dive into writing machine learning code. We have done a bit about Python. We talk about neural networks with Murtala. Last week, I think it was on deep learning. So I'm going to make a bunch of assumptions as we are talking because I believe that some of the things that I might have skipped when talking will have already been covered by the previous presenters. But if I talk about anything that you think maybe you are not 100% clear on, you can maybe indicate so that we'll allow you to talk and see if we will be able to clear your doubts. So this session is primarily focused on using Python to build machine learning models or machine learning apps. But maybe I will see later in your machine learning journey, you don't always need Python or TensorFlow to build machine learning models. But for the purpose of this, we are going to focus on Python, TensorFlow, and Keras. So now, what is this TensorFlow that I've been talking about? TensorFlow is an open source platform for machine learning. TensorFlow was developed by Google, and I believe it was open source, that is released for use free of charge in 2016. Before 2016, Google have been using TensorFlow in-house as part of the Google Brain team, where they use it to power some of their products, but the public wasn't aware of what they were using to achieve that. So in 2016, Google decided to open source TensorFlow and bring it out there free of use for anyone to use. So TensorFlow provides comprehensive ecosystem of tools for developers, enterprises, and researchers like you or me who want to push state-of-the-art machine learning and build scalable machine learning powered applications. So TensorFlow is designed for ease of use. That's why it's aimed at not only developers or enterprises, but also researchers. Because sometimes as a researcher, you are not a full-time developer. You only have maybe the skills, or you only learn what you need to know to conduct your research. So TensorFlow is designed with a wide audience in mind so that it's not restrictive to maybe people that are only hardcore developers or people that are hardcore researchers. So they try to balance it and make it easy for everyone to start using TensorFlow without wasting much time. And one of the advantages of TensorFlow is I think its ability to run across a wide range of devices. As you can see, it runs on CPU, GPUs, and TPUs. And as I've mentioned, it's licensed under the Apache 2.0 open source license. So now, what's this TensorFlow? And by looking at the name now, you can see that it is divided into two parts. We have the tensor part, then you have the flow part. And this is by design or by intention. Tensor and flow. So tensor is nothing but a multidimensional array. We represent data in a system as arrays, as you know in computers. So it supports 2D and multidimensional arrays. That's TensorFlow. While the flow part of the name just deals with, let's say, a graph of operations. Because if you are familiar with TensorFlow or machine learning applications, you might have heard of the concept called DAG, called directed acyclic graphs. I think we'll talk about them in a bit. So the flow part of the TensorFlow name just refers to a graph of operations, because every mathematical computation is expressed as a graph of operations in TensorFlow. So nodes in these graphs are operations, and edges are what we call tensors. Okay, let's see. So as you can see, because I know most of us here are mathematicians, this is just to give you like a graphical representation of what I just talked about. As you can see the difference from from a scalar to vector to matrix, and what a tensor is. So as you can see, a tensor is just a multidimensional matrix that represents, let's say, a set of values. Also, this is just to shed more light of what a tensor looks like. As you can see, all the previous scalar vector, we started from a one-dimensional to two-dimensional, but you can see that when we talk about tensor, it's a three-dimensional. Data is represented in 3 dimensions. I know this is not, it's just to prepare your mind. I know when you talk about deep learning, you have been introduced to all these concepts. I was there when you were talking about neural networks, and I believe you have heard all the background about all these things. So now, talking about the flow, I say computation is defined as a set of a DAG, that is directed acyclic graph to optimize an objective function. Because at the end of the day, when we are training a machine learning model, all we are trying to do is just to optimize a function, a mathematical function. So this graph is defined in a high-level language like Python. Sometimes it's not in Python, it's maybe C++. If you are an R developer, you have had experience with how to build a machine learning models with R, and many other languages that you can build, because nowadays you can even build a machine learning model with JavaScript. As when we are talking about the TensorFlow ecosystem, we'll talk a bit about that. So our graphs are compiled and optimized, and then they are executed sequentially, either in parts or in full. So sometimes you can decide to compile a portion of your graph, execute it, compile another function, execute it, but sometimes you just run it end to end, and you get your result. So these tensors, this data that we talked about earlier, flows through our graph. That's when we are executing these tensors, they tend to flow through our graphs in a sequential model or otherwise. And TensorFlow, one of the advantages of TensorFlow is it can compute gradients automatically. When we are talking about gradient descent in deep learning, I think this is just referring to that. So maybe as a beginner in TensorFlow, because the TensorFlow ecosystem is quite wide and large, so sometimes you tend to get lost if you're trying to understand everything at a go. It takes years for anyone anywhere in the world to become an expert in anything. So, but for now, as a beginner, all you need to do is you need to focus on these 5 easy pieces, because they are the foundation of the TensorFlow framework. These pieces are referred to as the tensors, variables, modules, our gradients, then our functions. So now, what do we mean by these things? So when we talk about tensors, we are talking about the representation of our data, because we need data to train a machine learning models. And to train a machine learning models, we are training what we call weight. We are optimizing what we call weights, which are a set of variables that we tweak and tweak and tweak until we arrive at a model that is fairly accurate for the purpose we are trying to train it for. We have what we call gradient tips used in training of those weights. We have what we call modules, which are our models. Then sometimes we use functions to accelerate the training or inference process. If we are using maybe hardware accelerators to optimize our machine learning training algorithm. So now, TensorFlow is not the only machine learning framework out there. There are tons and tons of machine learning frameworks out there. TensorFlow is one of them. So you'll ask yourself, why TensorFlow? Why not the others? And it is a valid question because we are asking you to learn TensorFlow. You might say, but I want to learn Python. Why TensorFlow? So I will just outline some of the advantages of using the TensorFlow framework to train machine learning models. As I've said earlier, TensorFlow is designed for ease of use. So whether you're an expert or a beginner, you can use TensorFlow to train your machine, to build your machine learning models, productionize your machine learning model, just deploy your machine learning model out there in a short space of time, maybe in a day or two. You can perform powerful experiments for research, and TensorFlow has a very wide community because it is an open source project and Google is one of the biggest companies out there. So TensorFlow has a very, very wide community because you can have people that use TensorFlow in all corners of the globe. And that's why we do have a TensorFlow user group in the remote part of Nigeria called Bauchi. We have TensorFlow user groups in the middle of London. We have TensorFlow user group in the Silicon Valley, San Francisco. We have TensorFlow user groups in China, in India. So you can see the scale of like the community of people using TensorFlow. So, and this makes it easier for you to prototype or to use TensorFlow in your production system because at the end of the day, for anyone who's familiar with any bit of programming, you know that whenever you're designing a system, you tend to run into roadblocks. You get into you get to experience errors in your code, and sometimes all we do, because we are all developers, we know, we go online, we search for answers, and we solve our problems. But now, if there are no more other people using that framework you are using, you'll get stuck for a very long period of time, and at the end of the day, you might even abandon your project because maybe you are stuck and you couldn't find a solution to your problem. So why TensorFlow? Okay, these are some of the advantages of using TensorFlow, and maybe to reiterate, TensorFlow offers multiple levels of abstraction, so you can choose the right one for your needs. You can use or you can build models using like high-level APIs like Keras, which makes getting started with TensorFlow and machine learning very easy. And TensorFlow provides you with a direct path to production because you are building your models not for show or to impress people, but to productionize your solution, put it out there for people to use and see if your model is solving a real world problem or not. So you can deploy your TensorFlow model. You can train a TensorFlow model on your device, on your local computer, and you can deploy it on servers or on edge devices or on the web, or you even deploy it on your mobile devices. It's very easy to do that. With one model, you can deploy it across almost all the platforms out there. And to some extent, once you have your training model, it's language agnostic, meaning that once you can just decide to deploy your model out there, just provide an API endpoint, and people can be able to use your endpoint for inference, irrespective of the language they use to design the front end of the application. And TensorFlow gives you the power to build and train state-of-the-art models without sacrificing speed or performance. It's very, very, very fast to use TensorFlow because sometimes, some of us that are familiar with the recent advances in these LLMs, these large language models, you will tend to realize that these models are not easy to train. They are quite expensive. You need computer resources that the scale is even mind-boggling to see, to put it in the context. Because I think it was just last month I was giving a presentation on Keras. We were talking about this chat GPT, and we performed a simple Google search on what it cost OpenAI to train this chat GPT model that we use. That's all the hype these days. People are talking about what chat GPT can do. Is going to replace developers and the rest. I'm not going to talk about that. We all have our opinions. But then I think the point I was trying to make is that it was costing them around, if I can remember, it was either 1 million US dollars or 100,000 US dollars per day to train these machine learning models. So just to show you, just to give you an overview. Now, if this Alumina is taking, let's say, 100,000 US dollars per day to train ChatGPT, that means it's costing them 1 million US dollars every 10 days or $3 million every month to train ChatGPT. And they are always retraining because as we are feeding it, as we are using it, we are feeding in more data. They are retraining the model to take into account all these new advances. Okay, when we are talking about designing end-to-end machine learning systems, we'll talk about why it is important to train these models so that the models will not degrade and start giving you wrong answers. Okay, so moving on, TensorFlow also supports an ecosystem of powerful add-on libraries and models to experiment with. So if you are using TensorFlow, there's a bunch of pre-trained models out there. You don't even need to train your model from scratch. Some people have trained machine learning models with a higher level of accuracy that you can ever achieve because they have the resources, they have the data, they have the computer resources, and they will decide to put it out there for people to use free of charge. And that's one of the beauty of the open source movement. People that are always trying to push the limits of what's possible. A person can spend a year or 10 years designing a system, and the system will be perfect at what it does. But instead of using the system to make money, the person can decide to open source it for people to use free of charge. So the open source movement is quite amazing, and that's why we are talking about TensorFlow today, because TensorFlow is an open source framework. Anybody from anywhere in the world can contribute to TensorFlow without any limitations or restrictions. So now, other reasons why you might consider using TensorFlow. TensorFlow has wide acceptance by not only in the academia but also in the industries. Because now at the end of the day, I think this is one of the reasons why you will decide to go and learn a framework. Now, if you learn a framework that people are no longer using, where will you get a job to apply the skills you have learned? Because at the end of the day, it's all about the money. We are learning these skills to be able to maybe solve real world problems and at the same time get paid. And that's the truth of the matter. So this is maybe one of the reasons that you might consider using TensorFlow. As you can see, companies like Airbnb, Coca-Cola, Twitter, PayPal, and a bunch of other companies out there are using TensorFlow in their production systems. And even Google, I think almost all of I don't have the number at the back of my mind, but they are using TensorFlow across almost all their products that you are using out there, whether you are using Gmail, whether you are using Google Search, whether you are using Google Docs. Even for those of us that are using this Google Meet here, yes, we are using TensorFlow in one way or another. So that's enough of TensorFlow. Let's move to the brother of TensorFlow called Keras. And you can learn more about Keras at keras.io. That's their website. If you want to know more about TensorFlow, just type tensorflow.org in your search bar and it'll take you to the TensorFlow website and you'll see all I'm talking about on TensorFlow. So now Keras. So Keras is an API designed for human beings. So I'm taking this definition directly from the Keras people, from the creator of Keras, so that to make it relatable, you say they are designing Keras for human beings, not for machines. Because at the end of the day, it is human beings that are building these systems and human beings that are using these systems. So Keras follows best practices for reducing cognitive load. It offers consistent and simple APIs. So Keras is all about simplicity of use and consistency, because it doesn't make sense for me to learn Keras today and after a year or two, when I come back to use Keras, you will discover that they have changed almost everything I know about Keras. It's quite frustrating and it's not even recommended. So Keras is designed with simplicity and consistency in mind. It minimizes the number of user actions required for common use cases, which means they have automated less, almost all the headaches, that's repetitive tasks that developers tend to perform when designing machine learning models. And it provides a clear and actionable error messages, because there are some frameworks that if you run into error before you even let's say discover what the error is all about, you'll have spent maybe an hour or two wasting your time. But Keras, because it's all about simplicity, consistency, and speed, they provide with clear and concise error messages for you to just go ahead and solve the problem and arrive at your result in as little time as possible or as fast as possible. So Keras is an API that is built on top of TensorFlow for now. We'll talk about Keras ecosystem later on, but for now, let's say now you use Keras in conjunction with TensorFlow. You can use Keras as a standalone, but is not recommended to some extent, because Keras and TensorFlow complement each other. There are things that you can use TensorFlow to perform very easily. There are things that you can use Keras to perform very easily. So the beauty of it is that you can use TensorFlow and Keras together concurrently. You pick what you need to pick from TensorFlow, you need to pick what you need to pick from Keras, and you run it, and it will give you a result. And I think from the release of TensorFlow 2.0, it come Keras come included with TensorFlow. So once you install TensorFlow from 2.0 above, I know they have depreciated all the TensorFlow to 1.1. Okay, any version below 2.0, I think they are no longer maintaining it, because they are trying to make it very easy to use TensorFlow. That's why they introduced that TensorFlow 2.0 just I think 2 or 3 years back. So from TensorFlow 2.0, once you install TensorFlow in your system or in your device, it is automatically company installed with Keras. You don't even need to install Keras separately. But before than that, in the olden days, you need to install TensorFlow, you need to install Keras, and you need to find a way to make them work together. But you don't even need to do that now with recent advances in those frameworks. And you might ask yourself, why Keras also? And it's quite a good question to ask, because I can't just come here and tell you use TensorFlow, use Keras without giving you my reasons of saying why you need to do all these things. So from the definition, we talk about ease of use and rest. So Keras is all about simplicity, flexibility, and it's quite powerful. It gives you the power, or the yeah, it gives you the power to do what you need to do in a very short amount of time, and with a little bit, with a lot less of problems if you are not using Keras. So the creator of Keras, Francois Cholet, said that the purpose of Keras is to give an unfair advantage to any developer looking to ship machine learning powered apps. So Keras focus on debugging speed, code elegance, conciseness, maintainability, and deployability. And I think that's what makes Keras very, very popular with people out there, because not only can you build machine learning models with Keras, it makes it hassle-free for you to maintain your code, because If any one of us has developed any system before, you know what it means to say this system is easy or hard for you to maintain. Because maintaining systems is not a child's play. You build a system, maybe you write the code yourself after a year. If somebody gives you that source code, you will say that I've never seen this code in my life. And you are the one that built it. And that's the truth of the matter. And Keras make it very, very easy for you to deploy your machine learning models. Because at the end of the day, the primary reason we are building these models is to solve real world problems. We are not building models for gimmick or to impress others. So now, if I am able to successfully build a machine learning model that can solve a problem and maybe even make me money at the end of the day, without being able to deploy that model for people to use, that model is as good as, let's say, not even developed in the first place. Because whenever you build a model, it needs to be able to provide a value. And you are wasting tons and tons of resources to build those models, time, computer resources, you collect data, you spend a bunch or a ton of money to even acquire the computer resources, or you rent virtual machines online, you pay Google because they won't give you their virtual machines for free. And at the end of the day, if you are not able to deploy your model, you have just wasted your time and resources. So Keras makes it very, very easy for developers to deploy their models after training. And when you choose Keras, your code base is smaller and more readable. So it makes it easier for you to maintain. And thanks to the power of accelerators like SLA and optimizations, Keras models are very, very fast. Maybe if a traditional machine learning model takes, let's say, 1 hour or 5 hours to train, maybe you can train the same model in 30 minutes using Keras. So it saves you the time and resources also. So the TensorFlow and Keras ecosystem has a lot going on for them. Uh, they have a lot of methods, classes, and functions that you just need to call and implement maybe a functionality that can take you maybe a day or up to a week for you to implement. So they have all these things in their documentations. Once you read the documentation, I want to do this thing. You just go read the TensorFlow or Keras documentation, and they will have a function or a class for you that you can just call, just import it into your notebook, you just run it, and you'll be able to get your result instantly. So TensorFlow have Keras, which I have explained earlier, is a high-level API that you can use on top of TensorFlow. And we have a lot of packages in the TensorFlow ecosystem. We have something called the TFX, that's TensorFlow Extended, that makes it very, very easy to build an end-to-end machine learning pipeline. That is from training up to deployment. Once you have your system design in a TFX format, all you need to do is just to initiate the process, just sit back and relax, drink tea, and at the end of the day, every step of the machine learning pipeline will be handled for you automatically. We have what is called the TensorFlow Lite that makes it very, very easier for you to even, let's say, like a magic to deploy TensorFlow or Keras models on mobile devices. We all use handheld devices, mobile phones, tablets, even smartwatches. We are using them. So using this TensorFlow ecosystem, you can train a model and deploy the system on your mobile devices in a matter of 1 hour. You can have a working prototype on your mobile device. We have what is called TensorFlow JS, where you use JavaScript to train machine learning models in your browser without needing to download. Even that's for people that maybe that are not familiar with Python. You can use TensorFlow JS to do that. And we have a bunch and bunch of other packages, resources bundled in the TensorFlow ecosystem. You can go to tensorflow.org to know more about this. For those of us that are coming from maybe data analytics background, we have NumPy. which is a packages for numerical computations using Python. So TensorFlow have inbuilt NumPy so that it makes it easier. You don't even need to install Python, NumPy separate. Once you install TensorFlow, you have NumPy, and it gives you the power to do whatever you can do with Python with NumPy. So, but at the end of the day, what do you need to know? That is, with all these tools that are out there, with all these libraries, with all these things, it's quite, is it confusing or overwhelming for you to learn everything at a go? So you need to focus on what do you need to know at this stage now. If I am a student, I know maybe I have a goal. If I'm a developer, I have what I need to achieve by learning TensorFlow. So I think that should be our primary focus. Is how do you get your head around designing the entire system? If you are a developer, if you are a researcher, you need to figure out what I need to know now to succeed in my choosing endeavor. That's a research field. And so this is just like a piece of an advice so that you will not tend to get lost. Sometimes you spend months reading with nothing to show for it. But now, if you focus on what you need to do, you read for a day or two, you try to test your code and see if it works or not. So now, up this, I've been talking about all the maybe background information you need to know about TensorFlow and the Keras framework. So I'm just going to talk about how to go about using these libraries. So after knowing about them, I think the next logical step is for us to understand now how do we use these libraries that he has been talking about. So now, the first thing we need to do now is to install and set up this TensorFlow or Keras in our systems. But maybe now before I go much further, I think we have talked about quite a bunch previously for the past 40 minutes. So if anyone has any observation or question, I think now will be a good time to raise it up before we move to the next phase of the presentation. Okay, Mr. Akendi, you can go ahead. Hello.
Can't you speak up? We cannot hear you.
Okay, he might probably have issues with his networks. So if you can just drop your message in the chat, I think. Okay, so I think we can continue so that we, in the interest of time. So now how do we install TensorFlow and Keras in my machine, in my local machine? So with just these few lines of code, you can install and import TensorFlow and Keras into your development environment. Um, I know most of us are familiar with Jupyter notebook by now. Sometimes you write your TensorFlow code in Python scripts and you run them. Okay. I think I have the TensorFlow and Keras the same. If they are not, what makes them different? Okay. So I think to answer your question, TensorFlow and Keras are not the same. But when working in the machine learning space, people tend to usually use them together. That's why we are introducing them together. During my introduction, I talked about TensorFlow, and I said that TensorFlow is a machine learning framework developed by Google, and it was open sourced in 2016. Keras is also another machine learning framework. It was developed by a guy or a person named Francois Chollet, and uh, I think the primary focus of Keras when he developed it is ease of use. That's why when we're talking about why Keras, okay, I think let me go back to what is Keras. When I was giving the definition of Keras, I said that Keras is an API designed for human beings, not machines. Uh, TensorFlow and other machine learning frameworks tend to be quite cumbersome in the sense that you need to learn a lot of preliminary stuff before you can start using them, because these tools are usually developed by people, or let's say the developers that know almost everything about that ecosystem. So we humans are biased. Sometimes we tend to make a lot of assumptions. That's why when I started this talk, I made an assumption that maybe most of us here were here to learn about machine learning using Python. And I said that was my null hypothesis. So now, with all these assumptions and bias from me, I tend to skip on maybe some basic information that I may need to maybe talk about if I am sure that I'm dealing with people that have zero knowledge of machine learning. But seeing that maybe you had for 6 weeks now you have been learning machine learning, I know that all these basic concepts were discussed by the previous speakers or presenters of this program. So now, when TensorFlow was designed, it was not very easy or very intuitive for people to get using TensorFlow right out of the box, and that was one of the problems they solved when they released TensorFlow 2.0. When I was talking about the release of TensorFlow 2.0, when they released before the TensorFlow 2.0, even if you write your machine learning code in Python, you can't just run it just like that. It won't run in TensorFlow. You have to enable what is called eager execution. This tells the compiler that, well, this person is writing this machine learning code in Python, so I need to convert this code from Python maybe to C, because at the core level TensorFlow is designed using C. Now, before you'll be able to compile the code and train your machine learning model. But nowadays, you don't need to do that. You can just open your notebook, and you will see subsequently in this presentation. You write a few lines of code in Python, and you can run your code, and everything will run perfectly. So initially, to attract, let's say, beginners like you and me, when TensorFlow was released, Google discovered that this Keras is very, very popular. So now, what do we need to do to get beginners, to start using TensorFlow so that they won't go to other frameworks? Now, let's integrate Keras into our TensorFlow ecosystem. So by integrating Keras, it makes it very, very easy for beginners to start using TensorFlow. So as I was saying, TensorFlow is a separate framework, Keras is a separate framework. But now, over the years, this clear line of separation has been blurred in the sense that you can install TensorFlow and it will come built in with Keras. So whenever you need to use a Keras function, you can just call it without any headache, without any installing Keras separately, and it will run perfectly without any optimization or any debugging. You understand? So TensorFlow, let's say, is the layer, while Keras, as you can see from this division, is an API. We all know what API is, or application programming interfaces. For those of us that are familiar with web development, we know what API is. So Keras is an API that was integrated into TensorFlow to make it very, very easy for beginners to use TensorFlow. I think I will leave it at that. And before I continue, I would like to ask if at least I'm able to explain it a bit clearer. Okay. Okay, Mr. Usman.
Assalamu alaikum. So based on your explanation, it gives us a clear picture about Keras and TensorFlow. So now, specifically, if somebody asks us like from outside, what are the basic difference between the two terms? So what can we suggest? Since we understand that this Keras is just like an open API designed for human, not machine, producing cognitive load, and it provides actionable error messages. And you can integrate these Keras into TensorFlow. So now, specifically, what are the distinct differences between the two terms since they can perform the same task?
I
Okay.
think I will
So,
just quickly
okay,
so
continue.
that we'll just be over with these TensorFlow and Keras uh, differences.
Okay.
TensorFlow, as mentioned by Nuruddin, is the general framework, right? Like it's a
Okay.
machine learning framework. You can do bunch of other machine learning stuff in TensorFlow. But in
Okay.
Keras, it's like basically a neural network framework. You can only do neural network stuff in Keras. They don't have that capabilities to do other machine learning stuff. It is only targeted at neural networks. So if you develop a Keras model, that is a neural network model, and then you feel like you want to add other functionalities that Keras don't have, you can easily adopt that model in TensorFlow. You don't have to rewrite anything because the two frameworks are connected. So you can just add your model into TensorFlow and add other machine learning functionalities. So like TensorFlow is the broader framework. It has other functions that Keras don't have. Basically, Keras supports neural networks. That's it.
Okay.
Thank you.
Okay. It's now clear. Thank you for your response.
Okay. And just to put what Mala Amino has said into perspective now, I know we all know about Google. I'm going to assume that we all have heard about Google and the amount of resources Google has. But now without okay now let's say maybe let's get a quick show of hands. How many of us have heard of Keras or the guidance of Francois Cholet before now? So I think just two people, huh? Or three out of the bunch. So okay, to put what Man Amin was saying into perspective now, when Google was designing TensorFlow now, let's assume now that Google has 1,000 developers designing TensorFlow, while maybe in the Keras team, they are not up to five. You understand? So there are, as Madam Amina has mentioned, there are a bunch of stuff that you can do with TensorFlow that you cannot do with Keras. But now, Keras is very easy for you to use. Let's say now, TensorFlow is the engine. You understand? Whatever you do, you need TensorFlow behind the scene because it has tons and tons, hundreds of thousands of functionalities that you cannot get with Keras. While Keras is very easy for you to use. So now by combining the two, you have the power and the ease of use. And now you are basically a superhuman. Cool? Without wasting much time, you have the power of TensorFlow behind you. You have the ease of use of Keras at your hand. And let's say within one day, you will be able to design a deep learning model or a machine learning model. While previously, maybe in years before the advent of these deep learning frameworks, to design a machine learning framework, yeah, the machine learning system, wow, it can take you maybe up to a month without you knowing what you are doing, even at the preliminary stages of your production. So by combining these two frameworks, this TensorFlow and Keras, and it was a conscious decision by Google. It was a conscious decision because they know that if we have TensorFlow, let's assume that this TensorFlow is the best deep learning framework out there. It's not easy for people to use. Nobody will come and use that tool. So now, how do we attract people into this TensorFlow ecosystem? They went out there, they did their research, then they discovered that there is this tool called Keras out there being developed by this guy. But this guy, he made the framework very easy to use. But now, you know, No system is perfect. No system is perfect. It has maybe some drawbacks or some bottlenecks. So now let's throw the power of Google behind this Keras framework. Let's integrate this Keras into our ecosystem so that people that are already familiar with Keras can now use TensorFlow, and people that are new into using TensorFlow can go ahead and learn Keras in maybe 1 week or two, and they'll become machine learning engineers. So it's a win-win. But at the basic level, there are two different frameworks, and later on in my talk, I'm going to talk about that because now Keras has the power to not only for to be used in TensorFlow but in other machine learning frameworks. Now you can use Keras in other machine learning frameworks. That's what I'm looking for. You can use Keras in other machine learning frameworks, not only TensorFlow. Now, but this is just a recent development. Previously, last year, you can use Keras in PyTorch or any other machine learning framework. But now you can use Keras in all those frameworks. So now let's go ahead and start uh, talking about how to be a proper machine learning engineer. Now by running through some codes. Okay. So now this basically now with these 4 lines of code, you can install and import TensorFlow and Keras into your development environment. That is into your maybe Jupyter notebook if you are using Jupyter notebook. By using pip install TensorFlow, this is not the actual command because there are different iterations of TensorFlow. Let me see if, okay, no problem. Let's assume this is the command because we have different iterations of TensorFlow. We have TensorFlow that is optimized for use with CPUs. That is, you can install it on your local machine, or TensorFlow that is optimized for with use for GPUs if your machine supports that, or if you are using virtual machines. And there are TensorFlow nightly builds that has experimental TensorFlow builds that you can use that about the unstable versions. Don't worry about all those things. By using pip install Keras, you can install Keras into your development environment, and Keras is ready for you to use. And let's assume now these packages have already been installed into your system. Whenever, because you only need to perform the installation once. Once you install TensorFlow in your system, it's there for life unless someone removes it. So all you need to do now, whenever you are designing a machine learning system, is just import TensorFlow, import Keras, and you are ready to go. Import TensorFlow as TF. Now, if you are using alias in Python, import Keras. You can decide to give it an alias, but it's normally used as Keras, as you will see when you are running through some code, and you are ready to go. So now, I think, okay, Mr. Usman, I do have a question, but let me get your question first before.
Sorry, sir. I heard you say this pip install TensorFlow is not the proper way of installing the TensorFlow. So does that mean that when we use pip install TensorFlow, there are some functionalities that may not run properly, or what are you trying to say here? Thank you very much, sir.
Okay, absolutely. Absolutely, you are right. There are some functionalities that might not use because, as I have mentioned, there are different flavors of TensorFlow. Now, let's assume now you are using a local computer, and I'm going to assume that maybe your computer doesn't have an inbuilt GPU. You know what GPU is, right?
Yes, sir.
Okay. You know GPUs, we know TPUs. They are
Yes.
hardware accelerators that allows us to that speeds up the process of our training code. So now, if you install TensorFlow, now if you have a system that has GPU and you go ahead and install TensorFlow that only supports CPU, your GPU will be sitting idly while it is taking you maybe 20 hours to train a simple machine learning model that can be trained in less than an hour. You understand? So now, but if you go ahead and install the right TensorFlow build that is optimized for GPU, now whenever you are training a machine learning model, your operation is going to be much faster. You'll be able to achieve more in a short period of time. But now, this is just for illustration purpose. If you want to know more about, that's why I'll always be referring you to the TensorFlow documentation or the Keras documentation. What you need to do to know how to install TensorFlow is just go to the TensorFlow website. It's tensorflow.org, I think. Yeah, I've dropped it in the chat, tensorflow.org. Just go there, read through the documentation, and you'll see what I'm talking about. That's also the same way of to install Keras. Then yeah, okay. I did say that I had a question. Now, this code I wrote pip install, let's say TensorFlow pip install Keras. Now let's assume we want to run this command in our Jupyter environment. And we know there's a trick to installing Python packages if running inside Jupyter notebook. Can somebody just pinpoint what I omitted in my code? That's the first few two lines of code. Pip install TensorFlow, pip install Keras. If I run this inside a Jupyter environment, it won't work. It will give me an error. Why?
Yes, sir, because we need to create a variable that will represent the TensorFlow and that of Keras. So usually we add TF for representing TensorFlow and KS for representing Keras.
Okay, any other contribution? Okay, thank you, Mr. Osman. Uh, thank you very much. I think what you are talking about is how to use this Python alias, because now if you install TensorFlow as TF, we are giving it a short form. So whenever we need to call TensorFlow, we call it TF. What I'm referring to is this first install commands: pip install TensorFlow, pip install Keras. Okay, what I omitted now is that if I'm running these commands inside a Jupyter environment, assuming now I'm running this code inside Google Colab, I will need to append the beginning of before this pip install. I will need to put in is it exclamation mark to tell my Jupyter environment that I'm running this as a Python command, so that whatever operation it performs, it will pass the operation to my Python environment. Oh, that is the underlying engine that my Jupyter notebook is running on. Because what we are doing at this stage is we are just importing TensorFlow, we are just importing Keras, and these are already installed systems. So before we install packages, sorry, so before now if we run TensorFlow, import TensorFlow, import Keras, and our system says that TensorFlow is not installed, Keras is not installed, we need to install them. That's why we need to run this pip install command. But in running this pip install command, if we are running it inside a Jupyter environment, it won't work. We have to append it. Before the pip here, the first thing I will put is exclamation mark, if I'm right, and then followed by
Yes,
the pip install.
yes, sir.
Okay, that's what I was trying to say. Thank you. Okay, someone has contribution.
No,
Is it
I
Mr.
wanted to say that we omitted exclamation mark and you already said it.
Pardon? I didn't get it.
I wanted to say it's the error of the code you have been asking is an exclamation mark is omitted before the pip. So it won't work in Jupyter Notebook unless it's when put an exclamation mark
Yeah,
pip installed and the TensorFlow.
absolutely. Absolutely. Thank you very much. Mr. Usman?
So I'm sorry for just like interrogating with so many kind of questions because I'm very novice to this program. That's why whatever thing I see is not clearer, I used to make a question and ask. So my question is that so now, like for me, I'm using a computer that using CPU, not that of GPU. But later on, very soon, maybe I've been thinking of migrating from GPU computers. So, but I had you been saying that for maybe for instance, if someone install if you're using TensorFlow and he import this library as if installed TensorFlow, maybe he's using up a computer that's using CPU, then his GPU will remain idle. So now, what makes someone to think that this is a specific one to use and this one will utilize your CPU? Like for instance, I already created my model using a compute core i7 that use of CPUs. So now, if I migrate to GPU, that means that I may have a problem if I run the same model. So what will make me to so that my model will work perfectly? So thank you very much for your contribution, sir.
Okay. You don't need to apologize for asking question, and this is a very insightful question. Um, if you migrate your code to a system running on GPU, you won't have any problem. Why? Because the system will just execute your code on the CPU. It will just ignore your GPU. That's what I'm saying. And it's not efficient. Why do you have this GPU if you are not using it? So you need to take advantage of that GPU and use it. That's what I'm saying. So now, if you write your code and you didn't optimize your code for use with GPU, your code will run perfectly, but it's going to be very slow. As anyone who has trained any machine learning model before, training a machine learning model, especially maybe if you are doing, let's say, uh, what do you call it, computer vision stuff, is very, very, very slow because images are represented in 3 dimensions, I believe. So now you have to compress all this code, flatten your code, run it on top of your CPU, flatten the code that is, run it on CPU. Well, if you are using GPU, you can pass much more information. I think that's the accurate what I need to use. GPU can perform more computations than CPUs. By logic, we all know that. So they are, by extension, much, much faster than CPUs, basically. So now, if you have a GPU, you are not using it, you are wasting time. Because a machine learning model that you can train on GPU in 30 minutes can take up to 5 hours on a CPU.
Definitely.
So, but it will run perfectly. But then, if you have GPU, if you install the TensorFlow that supports GPU, you can optimize your code to get advantage of that GPU, and your training process is going to be much, much faster, and you reduce the workload on your CPU.
Thank you for clarification.
Okay, thank you. So moving on, I think we have shown how to install the necessary libraries before you start doing anything. So the next logical step in training a machine learning model is just to create your data pipeline. That is, you need to pass your data because you need data to train a machine learning model. And this data, you just don't take any data and just dump it into your code. There is a process of feeding that data into your model. So there are a set of tools and processes used to automate the movement and transformation of data between maybe the initial stage of your model, maybe into the up to the training stage. That's what we call a data pipeline. So you need to create a data pipeline, and with these few lines of code, you can see that TF the data, the data set. This is one of the functionalities of the TensorFlow framework. You can take the TF data library, and it will handle almost all the steps needed to transform your data before use in your machine learning application, because you can't just take an image and pass it to your model and the model will give you a result. You need to transform your image. You need to perform what we call pre-processing. Pre-processing. Maybe in your next week, when you're talking about computer vision, they will show you how to do that. So you need to create a data pipeline for it to be able to replicate what you want to achieve, because it doesn't make sense for you that anytime you want to pass your data into model, you have to perform the same process over and over again. Because now, after passing the data in, after loading the data, you need to maybe shuffle your data, batch the data, you need to transform the data by, let's say, normalizing the data or standardizing the data before you pass the data to your machine learning model for training. So there are a bunch of processes you need to perform on your data. So by creating a data pipeline, it will handle everything for you. That's used to you automate the movement of data from the initial stage of your machine learning model up to the last stage, and it will handle everything for you. so that whenever you have a new data coming in, you just need to pass this data into the pipeline without doing anything, any other work. This data will undergo through the same transformations that the previous data has gone through, and you get your result in an instant. Then, after transforming your data, because now I'm going through the different stages of training a machine learning model. So after getting your data, transforming the data, that's pre-processing your data and make it in a machine readable format. The next step is for you to create your model. So now we have been talking about models. And as we know, models are just mathematical functions. So now, before training our models, we need to even create our function, right? We need to define our model with their parameters. So with these few lines of code, just 3 or 4 lines of code, you can define your model using the tf.keras.models. You can see that now we are using Keras. But first thing we need to do is we call Tensorflow. Then from Tensorflow we call Keras. Then under Keras we have what we call models. Under the models is it library, we have what we call sequential models because there are different kind of models in TensorFlow and Keras, which we are going to talk about in a bit. So we don't even need to know everything here. This is just to introduce you to how easy it is to build machine learning models. Very, very easy. This is how you create a model in machine learning. Your model can have any number of layers, and these layers they determine the complexity of your systems. We have a number of nodes in each layers, and we have what we call activation functions, as you can see, called tf.nn.relu. That's why when we are using the relu activation function or the softmax activation functions for maybe giving you a final prediction. Let's not bundle you with all this useless information for now. You are going to know about all these things as you start building your machine learning models. So this, I think what I want to talk about a bit is this activation function, because after training your model has parameters. So sometimes is it necessary? Let's not go to the next stage so that we can, in the interest of time. So now, after defining your model, you can see now here what we did is we defined a model. We call a sequential model with 2 layers inside, or one, and the case may be, because one is the input, one is the output layer. So we have maybe only one deep layer, if we can call it that. Then we need to compile our model. For programmers, we always need to compile our code so that it will run without any hitches. So this is the model compilation stage. We run the command model.compile. Why do we run model.compile? Because we define our model initially. Okay, this is why we define our model. We say model, then we put our equality sign. We provided tf.keras.model. That's why we define the model. So subsequently, all we need to do is just to call the model since we have already defined it. That's why we call model.compile in this stage. So after compiling the model, okay, during the compilation stage, we we define our parameters. We call hyperparameters. Sorry, we define our model hyperparameters. We have what we call optimizer. So an optimizer is just an algorithm or function that adapts the neural network's attributes like our learning rate, our weight, and then it's just to make the training process much more optimized. Then we have what we call our loss function, which is just a mathematical function that just quantifies the difference between the predicted and actual values in our machine learning model. Then we have what we call metrics. These are just used for evaluation, but in a human readable format because we use our loss function for evaluation, but the loss function is not represented in a human readable format. But now when we pass all these things to our metrics, it prints our metrics in a human readable format. That's why when you are training a model, it will be showing you the progress report, saying that this is the accuracy of the model, this is the loss function, the loss of the model. As we are training, we are intending to reduce loss while increasing accuracy, because that's the end game. At the end of the day, that's what we are trying to do. We are trying to reduce loss And in reducing this loss, we are increasing the accuracy of our model. Basically, so with these few lines of code, you can compile your model, and after that, all you need to do to train is model.fit. You provide the x and y values. The x stands for our input features. The y stands for our input label. Epochs is the number of iterations. If we have callback functions, we pass them to the model, and you will see them all these things in action later on. So this is the model training stage. So by running this model.fit, now you will train your machine learning model. So after it finishes the training, it will give you an output. So now we need to evaluate our model. Evaluation is just to see how accurate our model is. Is it giving us the correct answer or not? Then finally, we perform inference of the model. So after evaluating the model, if we determine that this model is quite accurate, is good at what it does, then all we need to do at the end of the day is just to perform a prediction. That's when you have a model that's already trained, you can decide to deploy that model. So whenever a person is performing inference on the model, you just call the model.predict, you pass the data you need to pass to the model, and it will give you an instant output right there and then. So all that we have been explaining can be represented in these few lines of code. So by looking at this code, that you can see that we can train a complete machine learning model using this few lines of code. Yeah, from the import TensorFlow as TF to loading to using what is called the MNIST. This is our data set. You perform the split in this stage. There you divide our data set into train and test, because you need to do this. Here we define our model.tf.keras.sequential.model.sequential, sorry. These are our model layers. We started using the flatten layer. That's where we feed the data into the model so that we flatten it into a format that the model can be able to understand which type of data is this. We define our deep layers. We have our dense layer with 512 nodes with activation function of ReLU. We perform what is called a dropout. Okay, let me finish this so that you can ask your question. Then this is our output layer. We have 10 classes. We use the softmax activation function. We compile the model using providing our hyperparameters. We perform the training. You evaluate the model, and now we have a fully trained machine learning model. You just few these few lines of code. I'm sure it's to maybe in less than 15 to 20 lines of code, you can have a working machine learning model. Mr. Usman, can you?
Yes, sir. Where we define our model, and the second line where we define our dense layer, we mention 512 activation function equals to tf.nn. Please, what does this nn stand for?
What's the TF.nn? I'm assuming that it's a neural network stuff, neural
Oh,
network functionality, because this is an inbuilt function. We are just calling the function. You understand? We
okay.
are not the ones defining it. That's why
Oh,
you see that we call tf.nn.relu. You
okay.
understand? So instead of you to come here and start um, defining what a ReLU function is,
Okay.
TensorFlow has handled that for you. All you need to do is
Okay.
just to call it. I want this dense layer to have a ReLU activation function. And as you can see during the last part, we call tf.nn the softmax. Softmax is a different activation function than ReLU. We have different activation functions for different use cases. Okay, are we making sense, Mr. Usman? I think, is it clear?
Yeah, yes, sir. It's clear, sir.
Okay, so it has already been predefined by TensorFlow. By importing TensorFlow, you have access to all these tools, and that's one of the power of TensorFlow. As I was saying, when we are differentiating between TensorFlow and Keras. Now, with the TensorFlow now, all you need to do just call these libraries or call these functions or call these classes, and instantly it will perform this function for you. Because without TensorFlow, maybe you will need to spend maybe 5 hours creating a ReLU function, and at the end of the day, you will discover that this ReLU function, while I was writing the function, I made a mistake. So you have to come back and start all over again. But now, why do you need to do that? Since already somebody has already taken care of that for you. Just call it, use it, and you have more time to do other things, other more important things at the end of the day. So, as I was saying now, if you will be able to achieve this this thing that are okay presented on your screen, these few lines of code, you can run it from top to bottom without without any issues, without any error. You can safely call yourself a machine learning engineer. And I'm not exaggerating. Yeah, absolutely. So these libraries make it very easy for you to get started as a machine learning engineer. You can build models, and tomorrow if someone asks you, what do you do? You can tell them that I work with models, but not the other kind of models. You work with machine learning models. So yeah. So I think we are supposed to go on a short break, but before then, so that let me just talk about an overview of Keras API essentials. Now we know that the TensorFlow is the engine behind everything we are doing, while Keras is just an API built on top of TensorFlow. I've mentioned this before, and I'm reiterating so that there won't be any confusion. So there are different types of APIs that you can use to build machine learning models. Because in our previous example, we built what is called a sequential model using the sequential API of Keras. But sometimes maybe you come across a scenario, maybe when you have become a fully professional machine learning engineer, because okay, Malama Fatima, you can go ahead and ask your question. Okay, so I think Mr. Osman has a question about API, and I believe Ms. Fatima is raising her hand also to ask a question. Can you ask your question now so that I can answer them together?
Mine is not a question. I don't know whether it's from my side. Your
Okay,
voice is breaking also.
okay, okay. Hopefully, it's the network. Hopefully, can any other person hear me clearly?
Yes, we can hear you
Yeah, we
clearly,
can
sir.
hear you clearly.
Yeah, we
Okay,
can hear.
maybe it's her network. Sometimes it tends to happen if your network drop a bit, so my my speech will break. Okay, so to put API in a layman's term is, do we have any web developer in the house who works with APIs? Yeah, Mr. Abba, that's a bunch of Turanchi. You know, when we talk about APIs are basically like a wrapper or a layer. You understand that allow you to communicate with another system without you knowing the underlying is it technicalities that other system relied on. Now let's assume now we are using now TensorFlow on top of we are using Keras, sorry, on top of TensorFlow. Okay, let me take Mr. Abbas' definition. His API is like a bridge, that allows different software applications to communicate and work together. I think that's a perfect definition of what an API is, and I couldn't even put it better myself. I'm saying it's like a bridge, like a protocol of communication that allows uh, softwares to communicate with each other. Because you can have a software that is designed maybe in JavaScript, another software, okay, I can't, you will talk in a bit, where you have another software built maybe with C or C++ or C sharp or Java. You have another software built with an entirely different programming language like Python. And now, if you work in an organization as a software developer, maybe another team might design a software, and maybe the other team design another software with a different programming language. And these softwares need to communicate with each other. And they are all built using different technologies, different programming languages. Now, how do we make these systems talk to each other without me understanding the technicalities that the other system maybe had to overcome before they were able to deliver on their system? So that's why we need APIs. They just provide a streamlined process for us to communicate with other systems. Okay, I see a bunch of people have, I mean, so I think what we will begin with Mr. Akanti, then followed by Mr. Abba. The floor is yours. So you no longer want to talk again. Okay. So moving on, we have we can build machine learning systems. We can build TensorFlow models with with either Keras sequential APIs or functional APIs. Functional APIs, they are for much more advanced maybe models, and you are much more flexible using functional APIs, but are much harder to work with. And we have what we call model subclassing. And I think we have only 30 minutes, so we need to move fast. So now, this is basically how a sequential API looks like. Just to give you maybe a peep at what it looks like. And this is how a functional API looks like when you are building a machine learning model. And the main idea for using functional APIs is now following the DAG concept I talked about. That's the directed acyclic graph of layers. So the functional API is a way to build graphs of layers. As you can see, we define our input stage. We create a variable called x, where we define a dense layer. We pass our input to it, and during our the subsequent layer is the output layer. We define also a dense layer with all its parameters, and we pass our x variable to it. Then we compile the model, providing it with the input and our output. So we are much more flexible when building functional APIs. I don't want to bother you on bothering you with knowing everything here, because at the end of the day, we are just beginners. But I'm just putting it out there so that you know that these APIs exist. Maybe in your machine learning journey, you might come across these APIs, or you come across a scenario where the sequential API will not be fit for the purpose you are trying to use it for. So you know that we have these functional APIs, or you can even subclass your model, which is much more advanced than the functional API stuff we are talking about. So I think that brings us to the end of the first part of our model of our presentation, and I wanted to do that in less than an hour, but it seems I couldn't do that. But this second part of our presentation, just to give you a general information about what is needed to to design a machine learning system. And if we have any concerns, or we can just have a 1 minute break so that we can move fast, since it's 9:29, 11:29 now, 11:30 on my system. So we'll just go for 1 minute break so that we can come out, because this part, it doesn't have any technicalities, or it's just a bunch of currency and some illustrations we need to run through. And at the end of the presentation, I want to just show us how to train a simple machine learning model without even writing a single line of code. We can train a machine learning model. That's what I need to do. So we'll set aside 15 minutes for that, or 10 minutes for that. Then we have 5 minutes for question and answer. Then we go about our day. So just resume by 11:31 and continue from where we stop. Okay, so I believe we have stretched ourselves now, and we are back. Okay, go ahead, Jamila. Yeah. Jamila, do you have any question?
No, sir, it was just a mistake.
Okay, so it's nice to hear from you. We are supposed to contribute now, so it's good to hear from you. Okay, so now moving forward, I think so. When we are doing machine learning, I think this we tend to think about the arc of the workflow. That's how do we go about designing machine learning systems in TensorFlow or in any other framework. And I'm sure when you are talking about deep learning, you have been introduced to this concept. The first thing you need to do is collect data, because any machine learning system out there is as good as the data you have. If you don't have data, it doesn't matter how sophisticated your machine learning algorithm is, you are going to get rubbish at the end of the day. So your data is what will make or break your machine learning system. So you have to collect your data in the right format, and to ensure that the data maybe is balanced, even though there are some arguments against balancing your data set, which we are not going to talk about. But then you need to represent your model parameters, that's your model weights. You build a model, train those weights. Then if you have access to accelerators, you take advantage of that so that your training will be faster. Uh, then at the end of the day, you'll have a trained model. This is just an overview, don't worry about it. So I think there are 4 ingredients that makes up a machine learning system. So in order to build a machine learning system, you have to have these 4 ingredients. The first one is you have to have computational resources. Not because not any computer now. If I'm using, let's say, a Core i3 system, let's say 2 gig of RAM, and I decide to train a machine learning model system, I'm just trying to break my system, because at the end of the day, one of two things will happen. Maybe it can take me up to 3 or 4 days to train a simple model, or I'll end up damaging my system, because training a machine learning model system is a very computationally expensive and demanding task. So you need to have your computational resources. That's why we have been talking about GPUs, which you already know about. We have TPUs, called tensor processing units, that you can take advantage of to train your machine learning models in a fraction of the time that it might take you to train the models if you are not using these hardware accelerators. You need your training data and your testing data. Sometimes you need to validate your models. So if you have enough data, you can separate your data into 3 parts: training, validation, and testing. And then you need to have the state-of-the-art algorithms and tools like TensorFlow, tools like Keras and the rest. Then you also have to be creative, because machine learning is an art and science at the same time. You understand? So it's an iterative process. Let me put it that way. It's not that you can't just train a machine learning model just once and everything will be perfect for you. You have to iterate. Sometimes you have to iterate hundreds of times, or hundreds of thousands of times, or millions of times before you arrive at a functional model. So even in this process of iteration, sometimes you automate the process inside your machine learning pipeline, and you just sit back. And that's why it takes some models can take up to a year to train. Because if I can remember, I was reading something in one blog online. They were saying that it took almost close to a year to train this chat GPT model. I'm not sure, but I think I had it or I saw it somewhere. So you can use this TensorFlow and Keras for different machine learning tasks, because TensorFlow and Keras were designed to help you learn and build models easily with an intuitive and easy to use set of APIs like Keras. And TensorFlow ecosystem provides you with a rich collection of tools for building these models. So you can just call these tools, these libraries, these classes, and you can perform what you need to perform in a short amount of time. So now, how do you get started? Because TensorFlow and Keras can be used for different machine learning tasks. And maybe if I forgot to mention, TensorFlow and Keras at their heart, they are just deep learning frameworks. You know, when we in machine learning, we have what you call deep learning, which is a subset of machine learning. So when okay, let me not just waste your time on that. You can train image classification models, NLP models, that's natural language processing models. You can have time series analysis using this set of tools. And there are some concepts that kind of like a bit of advanced, but we need to talk about. Okay, so these are some of the advanced concepts in TensorFlow and Keras. We have what we call Tensor. You can run TensorFlow in what is called a graph mode, or eager execution mode. So in eager execution mode, I say operations in a model are immediately executed as they are encountered. That's why it is a sequential stuff. You start running your code if you are familiar with Jupyter environment. Whenever you run your Jupyter notebook, it starts the code execution from the top of the notebook sequentially up to the last code block in your notebook. That is a top to bottom approach of running your code. So if you are running your code in eager execution mode, the operations are executed as soon as they are encountered. While in graph mode, operations are first synthesized into a graph. That is, you define your graph, your flow, using maybe this dark concept, which will then be compiled and executed maybe as a bunch. Instead of your code running sequentially from the top of your notebook to the bottom, you can decide to define your graphs, put everything together, then you execute it at once, and it will run everything. But this is much more advanced machine learning engineers. Or if you are working on a big company that train these large models, you might come to use these approaches. And we have what is called the distribution strategy. This distribution strategy or distribution training is performed in such a way that now if you have an array of machines, because sometimes it's not possible for you to train your machine learning model in a single machine. Sometimes we can have maybe up to 5 or 100,000 or 1 million virtual machines running online, and you have large cache of data that you need to train across all these machines. The purpose of distributed training is to speed up your training process. Now, if one machine can take 1 year to run through your training process, now if you have, let's say, 100 machines, these 100 machines or 1,000 machines can run through the same process in an hour. So you are saving time. So that's why you perform distributed training or distributed inference online, but it costs a lot of money. It costs a lot of money, and that's why we are saying that it was taking almost up to 100,000 US dollars per day to train ChatGPT, because they are using these distributed machines, and they are quite expensive to run. So before we finish our talk, I would like to introduce you to what is called Keras code. This is a fairly new thing. It was released just 2 months ago. This Keras code is just a way for you to have a single code base. Because as I was saying, when we started, we were talking about that you can use Keras on top of TensorFlow. But I gave an example. I said that now, with recent advances, you can write your code in Keras and you can run your code either on TensorFlow or on PyTorch or JAX. So now, what happened during the release of this Keras code is they had to rewrite the whole Keras framework because initially the framework was about 135,000 lines of code, but now it's only 45,000 of code. So they have optimized the process, they have optimized the library, they have removed all unwanted code, and the Keras framework is now much faster. Now, Keras have support for not only TensorFlow, but for JAX or PyTorch or NumPy backends. So now you can write a portable Keras code. Once you have the code, you can run it whether you are a TensorFlow person, whether you are a PyTorch person, or if you are using JAX. Also, you can use this same code. So I think it was Usman who asked that question. So now you can write a single code and you can use it across different library, different machine learning frameworks. And I know PyTorch is very, very popular with researchers, while TensorFlow, initially it was very, very popular for developers because we all have our specific use cases, our specific requirements and the rest. So now, with the advent of Keras Core, you have all these advantages that I talked about earlier, and with additional advantage that now you can write a portable machine learning code. So now you are not restricted to one framework. You are not restricted to TensorFlow. You can write a code that can be executed on JAX or on PyTorch or NumPy backend. And it has support for hardware acceleration using XLA, because if you are familiar with JAX, you know that JAX takes advantage of accelerators to perform operations much, much, much faster. So this is just an example of a portable Keras code. Then you can run this code, you can run it in TensorFlow, you can run it on Python, you can run it on JAX, and everything will work perfectly out of the box without any headache. So basically, after all this training, at the end of the day, we need to be able to deploy our machine learning models into production. Because once your training is complete and you are certain that your machine learning code is perfect or it works for your specific use case, the next logical step is for you to deploy it on your website or on your mobile app for people to use and hopefully make money out of it. So now, the TensorFlow ecosystem allows you to deploy your model either on the web using TensorFlow JS, on a mobile using TensorFlow Lite, as I say, or on server using the TFX environment, that's the TensorFlow extended. Now, using the Vertex AI, on Google Cloud Platform, you can create an end-to-end pipeline where you can, from the training stage up to deployment stage, you'll automate all the process. So once you are training, once you have your data, you create a data pipeline, you create a training pipeline, you create an inference pipeline, you put them together, and you automate the process, put it out there, so that whenever you have new data, it will automatically trigger the training stage. After training, it will deploy the model for you, and without maybe pursuing a career ML ops. That's how to operationalize machine learning apps. You'll come across all those things on the on the TFX or Vertex AI platform on Google Cloud platform. So basically, just to put everything now into perspective, now using your Python environment, you can train a machine learning model. You can compile it either using Python or C++, whatever you require, or even using JavaScript. After building your model, on devices that support CPU, GPU, mobile devices, or even microcontrollers in some instances. You can deploy your machine learning models using the TensorFlow ecosystem. So it gives you the power to deploy your model. But now when it comes to deployment, that's where the problem arises. So TensorFlow provides you with end-to-end with the power to build a machine learning model from the training stage up to the deployment stage without any headache. And once so now we have been talking. So now because we have been talking about how to get started now, what's the easiest way for you to get started? So there are basically three ways where you can get started building a machine learning model as a machine learning engineer or as a researcher or as a student. You can use cloud-based APIs on the Google Cloud platform. You can go there. We have what is known as AutoML these days, where you design a machine learning system without writing a single line of code. All the process has been automated. Like it's like you are using Microsoft Word or Excel, just drag and drop. Click here, click there, click there. You train a machine learning model. Or you can use what we call pre-trained models using an existing model architecture, and you train it, and you take advantage of the retrained model, and you get in few steps you will have a model that is fairly accurate in what you are trying to do. Or at the end of the day, you can decide if you are confident in your skills, you can decide to develop your own machine learning models for no problems. And these are arranged based on order of complexity. It's very, very easy to use these cloud-based APIs. As I've said, you just click, drag and drop. You have a working machine learning model, but it's not free, it costs money. Or you can use what is called pre-trained models. These are models that have already been trained, but they are open source. For example, now you have a model that is trained on recognizing objects, maybe in your house, and you want to do something like that. So instead of you to start training from scratch, why not go take advantage of that and be able to achieve what you want to achieve in a short period of time? So now, I think I always like to finish my talk with this quote from Francois Choulet. That's the name of the person. This person is the creator of Keras. He's still alive. He's online. You can follow him on Twitter. This is one of his favorite sayings because when he was talking about Keras, he said that simple things should be simple, complex things should be possible. And I love that quote because at the end of the day, there is no point in making simple things to be complex. We are all trying to solve problems with these machine learning tools. So why make it very hard for people to get into? That's why he decided to create Keras to simplify and lower the technical barrier for people that are not hardcore machine learning engineers to use these machine learning tools to build solutions out there. So whatever you are doing, you should try to make things as simple as possible. And by doing that, hopefully all the complexities that we think are not possible shouldn't be possible. So I want us to I think what I'll do is I will drop a link in the chat so that you can visit the link, but I will demo it on my system so that you can see what I'm trying to do. Because there is this teachable machine, I will have loved for this presentation to be a physical one, but since we are constrained by various things, I will run this demo online. And this is like an example of what I was saying earlier, the auto ML stuff I was talking, that you can train a machine learning model without writing a single line of code. And I will share this slide at the end of the presentation so that you have access to everything, and you can visit all these things and run through the Colab. All these two links at the bottom, you can run through them, and okay, as you can open them and run through them, and I'm sure you won't have any problem. And I think I will do that. But for now, let me stop the presentation here. Okay, just give me a moment. Sorry, the last part, as I said, is going to be very, very fast because I don't want to take much of your time. Let me share the a moment, a moment. I will I'll share my screen now. Just tell me if you can see what I'm sharing. Okay, are we seeing what I'm presenting at the moment?
Yes, sir, it's visible.
Okay, yeah, thank you. So this is called Teachable Machine, and it's an experimentation platform by Google. I will try and see if I'll be able to train a simple machine learning model, an image classification model. I will open my camera. I will train the model on my face, Maybe I will just be doing some weird things with my face. Don't mind me. Just okay. So let me put my face without any expression. So let me do this. Hmm. So now I have gathered my data. I have two images here of my face. Here, without any expression. The other one, I'm putting my tongue out. Then what I will do now is I will train the model. And as you can see, it's preparing the data, it's doing everything for me. So now it's training. Now it's going through my data 50 times. That's going over 50 epochs. So now my model has already been trained. Now let's see if we'll be able to have a working machine learning model. You can even export your model so that you can use it in your Arduino. So now, as you can see, we have two classes at the bottom of the input. You see my face as I'm talking, and you can see now the model is a bit confused in real time. So now I want you to look at it now. I will compose myself and present myself to the screen. Let me see if the screen can be a bit clearer. Wow, what's going on? Okay, let's see. So you can see now it's showing class 1 because it was the first class that I will let me put my tongue out and you'll see what will happen. It's a bit confused because my camera is not very clear. What I You can see once I have no expression on my face, you can be able to add more classes and do the you understand. So that's what we call an example of a multi-class classification. Cool, and it's quite interesting if you ask me. And let me just put the link in the chat so that you can be able to try it on your own. And maybe later on in our next week class, you can tell us what you think of this teachable machine game I just did. As you can see, it's still active, still active. Once I put my you see, so now I have succeeded in training a machine learning application or a machine learning model, sorry, and in real time it's giving me my results. So now you can think of other specific use cases. You can use it maybe to, let's say, now let me add an additional class and maybe let me say the class is maybe flask. So now let me maybe hold my flags with me so that you can okay, let me record. So now we have an additional class. Let's train. So after training, you will see that it's training. So now, whenever I'm holding my flags up, you see that it will be able to recognize that I have my flags. It means if I want to change, if I do this. So these are example of things you can accomplish with machine learning. And I believe that I can just start my presentation from here. Let me see if I have any other thing I need to. Okay. So that's it for my for the demo. Let me. Okay. Okay, so I have two other links at the bottom on this page. I have two other links. This one is just for to show you a simple basic classification images of clothing using what is called the MNIST dataset. So I don't know if the structure of this program, but if it's allowed, maybe I can say that you can take second this second link as your take-home assignment, so that you can go and practice it on your own, and maybe in our next class session you can you can tell me what you think, because it's just a Google Colab notebook. Everything is there for you, but it gives you a better understanding of what I've been explaining here. It's just a basic image classification task. But I think since Madam Amino is taking image classification, so I'll just give it to you as a hint, so that when he's talking next week, you will you will understand what he's saying, or you'll have, so that when you even quitting now, you will be saying, Madam, this is so thing and this is so thing. So you even save him time to explain everything to you guys. Thank you very much, and thank you for the opportunity to present in this ML 101 program. And I would like to pass the mic to Madam Aminu. And if anyone has any additional question before I go, I'm ready to answer. So I'll hang around. Thank you very much.
Thank you, sir.
Okay, go ahead.
Hello, sir. Please don't forget to drop the links.
Okay, I think what I will do is I will drop the link to the whole slides. You know, I think you like it better, so that everything I have talked about will be available for you. Yeah, so I think the link is now in the chat.
Yeah, sorry, I just stopped.
I think thank
Very,
you. Thank you.
very, I just stopped. Thank you, madam, for this wonderful presentation. I hope you can hear me as well. All right, thank you for this wonderful presentation. And I just want to express why this presentation comes in handy in this course that we are doing, Introduction to Machine Learning. You know, nowadays everything is moving to the framework, libraries for simplicity and for ease of use. So I think no matter how uh, elegant you are or how expert you are in terms of machine learning, and you don't have a working framework, I think it's going to be difficult for you to find a work out there in the industry or even in academia, because the first thing, if you're applying for a job, that they will ask you after maybe your educational background is like, so which kind of framework are you familiar with? Because all the organizations that are out there, they use standard frameworks for their model definition and then production. So if you say you are a machine learning engineer, but you don't have any, you don't know about frameworks, you just know how to build maybe computer vision application, maybe natural language application, but you are confused. You don't know whether you are using a framework or not. You just know that you are using TensorFlow sometimes or using PyTorch,
but you don't know what is a TensorFlow, or you've been hearing about this TensorFlow, but you don't know what TensorFlow is. So this is the essence why we feel like we need to integrate these syllabus into our syllabus, that we need to we need awareness. Our students need to know what is a framework, how is framework being used in industries, and then what advantages these frameworks are giving us over the traditional way of implementing uh, applications or softwares. Just like Nureddin gave example, if we are to implement maybe a simple computer vision application to classify MNIST data set without framework and libraries such as TensorFlow and Keras, maybe we might spend the entire 2 hours of today trying to build maybe a convolutional layer or a single activation function before we can be able to integrate everything together to come up with a working model. So TensorFlow, or let's say frameworks and libraries, save time, and it makes it easier for everyone to use it. You don't even have to care about the what is working behind the scene, like the internal representation or implementation of such kind of functions, such as softmax or sigmoid. We just know that this is activation function to introduce non-linearity or whatever, but you don't need to find out how they are implemented. You just know that you can call them inside your layers and you can use them in your, and you just go and do your stuff. So it is very important to know about frameworks, to know which frameworks works for you, and to also say one or two things about the framework of your choice. If you are having an interview and maybe the interviewer may decide to ask you, okay, in machine learning, which framework do you use? Maybe if you are familiar with TensorFlow, you might reply with TensorFlow. That interviewer might be interested in asking you why TensorFlow, you choose TensorFlow over the rest of the frameworks. So by taking this course, I believe you have some feedback, some answers to respond to that kind of questions, because it is emphasized that Keras provides simplicity and easier to use so that everyone can use TensorFlow. You don't have to be a developer. You can be a research scientist. You can be a data scientist, and you can be from actuarial sciences, from social sciences. You don't have to be from CS background or from mathematics background to use such kind of stuff. So that is advantages of framework and libraries in terms of machine learning that we are studying. So I hope the facilitator have uh, impacted a lot of knowledge on us about the TensorFlow frameworks, about Keras libraries, and so on. And I hope we will not be reluctant in finding out and reading out more about this as we continue our journey to become maybe machine learning engineers or research scientists. Thank you, everyone, for joining. I would like to ask if there is any questions so that we can respond to it. Thank you. Questions? You can just unmute your mic and talk.
I think Malam Amino has made a very important point that you don't need to know everything now. This is just an introductory class. So at the end of the day, what is expected of you is just to know that these frameworks exist and the possibility of what you can do with them. Because it takes years to become expert in all this stuff, but at least now we have taken the first step, and I believe that in a year or two, most of us will become machine learning scientists or data scientists, as the case may be. And practice is always what I will recommend for you, because you can know all the theory, all the English behind all these things, but once you cannot do anything, you couldn't get a job. So it's very, very important that you practice all these skills. And I'm sure some of us can see someone just join, and I know the face, it looks familiar on LinkedIn. And I believe that he will tell you that practice is the key thing that you need to focus on at this stage of your career. Then finally, Malam Aminu has also talked about your background, and your background doesn't matter. And I don't want to talk much about this thing, but now I'm here, maybe taking a class on introduction to TensorFlow and Keras, but I don't have computing background. I didn't study computer science. I didn't study information technology. In fact, my degree was in agricultural production. I studied animal science, but here I am today. So, so please don't say that this thing is hard. I cannot do it. It's not that hard, but once you put your mind to it, I'm sure you can do it. So I think that will be my last word for the day. And if you do have any question, we are ready to respond. If not, it's not. It's very. It's my privilege to be amongst you, and I hope we can get to meet soon in the physically in the future. Thank you very much.
Thank you, Madam Nura. Any other comments?
Yeah, well, absence of comment, but today's lecture is different. So I already grabbed a quiz that is basically about today's lecture. I'll send you a link. You just log in and take. I think you just 10 questions or everything that is purely about today's lecture. You just want to see the kind of assessment on how today's lecture went. Is there any knowledge that is impacted or not? It's just kind of survey that we do to make us help understand how we deliver the course. So I will just send the link to our WhatsApp community group so that you will just log in and take. It's just like 10 minutes quiz. Nothing. It's not a big deal. So thank you everyone. See you next week. Yes, about you can talk.